We crack our heads trying to understand gravity, the black hole and quantum physics. But how much do we know about what lights up our cities? The idea behind dynamos, electromagnetic induction. In 1820, Hans Christian Ørsted noticed that the needle of a compass would deflect when it is placed near a current-carrying wire. Now this would have only happened when there was magnetic force, as if a real magnet was around. But he discovered that electric current could also produce a magnetic force, which would explain why the needle deflected. There was another physicist named Michael Faraday. He found out about this and he went on to think about the converse. If a current could produce a magnetic field, could a magnet then produce a current? His simple question sparked a revolution. His famous experiment proved to the world how we can produce electricity by using magnets. He discovered electromagnetic induction and concluded that indeed, when the magnetic field lines of a permanent magnet are being changed by a coil, it would induce an electric current. But, like any scientist, he failed before that. He experimented several times with a steady flow of current and nothing happened. He flicked the switch off and back on, and then he found out that only when the magnetic field lines are being changed, an electromotive force, or what you know as e.m.f, which causes electrons to move in the coil, would be induced. And that is current. That means if I were to place a stationary magnet in a coil, it would do nothing at all. But if I start moving the magnet, this magic happens. When the coil cuts or changes the magnetic field lines that all permanent magnets have, it changes the magnetic flux, which basically means the amount of magnetic field lines that are within the surface and perpendicular to the surface cutting in. Meaning to say, when the coil is perpendicular to the magnetic field lines, we would induce a maximum electric current. And when the coil is parallel to the magnetic field lines, we would get a minimum electric current. With all that put together, we have a dynamo, which on a large scale would light up your city. Magnets and coils, as long as you change the magnetic field lines by moving either the coils or the magnet, you will induce electric current. And there are many of them in these hydroelectric generators like the one I built here. Because it works better, the more and the bigger the coils are, the stronger the magnets and the faster you change the magnetic field lines. That's why we need big dams, big turbines and big magnets, so you can get more electricity. You were able to watch this video thanks to the people I mentioned at the beginning of the video. They made our computers and smartphones work, and even today, to manufacture AI, you will need power from electromagnetic induction. Now this is the best of physics you'll ever find.